everyone, my name is Stacey and today I'll be talking you through my proposal to undertake research on the effects of Lactobacillus Acidophilus on blood pressure, kidney function and liver function in adults. Health can be defined as a state of well-being. It is not just the absence of disease but the capacity to participate in all aspects of life. In 2024, 3.1 million years of healthy life were lost due to the burden of living with illness or injury in Australia. For the sake of this study, we will be assessing health through the context of blood pressure, kidney function, and liver functions. High blood pressure is a direct predictor of cardiovascular disease and mortality, as well as stroke. It is a poor association with health outcomes. This is also due to the constant pressure on the heart, caused by hypertension, that results in significant structural and functional changes to the myocardium that can lead to cardiac failure. Poor kidney function long-term also increases the risk for cardiovascular disease, as well as diabetes and cancer. With an ageing population, chronic kidney disease is the third fastest growing cause of death globally. This affects 1 in 10 adults in Australia, and when we look at the age group of 75 plus, symptoms increase to 1 in 4. For a slightly different perspective, economically, chronic kidney disease also costs approximately $10 billion per year in Australia. It puts pressure on both individual health and the healthcare system. Decreased liver function and metabolic dysfunction associated steatotic liver disease, a type of fatty liver not caused by chronic alcohol abuse, also have significant health implications. Risk factors for developing liver cirrhosis and chronic long-term liver conditions increase, as well as the rate of incidence for hepatocellular carcinoma. Collectively, the prevalence of poor blood pressure and decreases in kidney function and liver function are increasing every year. However, over 1/3 of poor health outcomes and disease burdens can be avoided or reduced with lifestyle modifications. This leads us to the question, can probiotic supplementation be a useful therapeutic tool in improving health outcomes in the general population? So why have we chosen L. acidophilus for this study? It is a probiotic bacterium belonging to the lactic acid bacteria family that is present within the gut. It aids in maintaining the equilibrium within the gut microbiome, supporting digestion, nutrition absorption, and immune functions. Studies have shown that this probiotic is a genetically stable species, more resistant to acids and bile salts found within the gastrointestinal tract than other strands of bacteria. L. acidophilus also has a high degree of safety and minimal adverse effects in healthy adults. Prior to putting together this research proposal, we have conducted a thorough analysis of existing literature. This has identified a breadth of studies focusing on the role L. acidophilus plays in improving health outcomes in animal models. A 2023 study using a rat model demonstrated that L. acidophilus could suppress liver damage in rats with colitis and cholestasis. Similarly, other studies have shown L. acidophilus can prevent hepatocellular carcinoma in rats with steatotic liver. Kidney function has also been demonstrated to improve with supplementation of probiotics, with a 2024 study showing that there was a reduction in kidney injury and an improvement in overall function in those rats supplemented with L. acidophilus. The limitations of these studies, however, is that while mice models and rat models may provide some insight into the potential benefits of supplementation, it does not completely paint an accurate picture of what the effects could be in humans due to fundamental differences in physiology. This leaves significant gaps in the literature on how L. acidophilus is useful as a supplementary tool in helping adults achieve positive health outcomes. There is also a significant gap in understanding the cause and effect relationship between L. acidophilus and blood pressure. There have been mixed results from studies, with one demonstrating that mice receiving a probiotic formula demonstrated some reduction in blood pressure. However, Ivy et al. Demonstrated no significant impacts. There seems to be much we can learn on this topic and something we hope to explore within our research. The aim of this research is to investigate the effect that 12 weeks of Lactobacillus acidophilus supplementation has on blood pressure, kidney function, and liver function in adults. We are using our research questions exploring supplementation effects on each of the dependent variables, blood pressure, kidney function, and liver function to focus our research. From this, our hypothesis is as follows. 12 weeks of probiotic supplementation improves blood pressure, kidney function, and liver function in adults. We are proposing a quasi-experimental design to understand the cause-effect relationship between supplementation and health function. Participants will be convenient sampled via advertisement and subsequently screened to ensure they are 18 years or older with no underlying health conditions. They will also be given a plain information sheet and consent forms prior to participation. We've determined the effective sample size for this study to be 32 participants. So moving on to our variables. The independent variable is the supplementation of L. acidophilus, where we will measure the dependent variables blood pressure, kidney function, and liver function. Additionally, we will seek to control the extraneous variables of diet and exercise by providing participants with a food and exercise log to complete in the 2 weeks leading up to supplementation. This will then be used as a baseline of each participant's lifestyle choices, and they will then be required to adhere to these choices throughout the 12 weeks of supplementation. This will ensure that any potential changes in exercise or diet are not the influence on the dependent variables. Confounding variables will also be accounted for during statistical analysis. This is things like gender and age. Firstly, we will be seeking ethics approval from the Queensland Health Human Research Ethics Committee. For our proposed method is to administer 1 tablet of L. acidophilus per day for 12 weeks, collecting data pre-intervention and post-intervention. Blood pressure data will be collected using the gold standard office measurement, which is a mean of 3 blood pressure measurements taken after 5 minutes of rest. Both kidney function and liver function data will be measured using a 24-hour fasted blood test using an autoanalyzer to run analysis. All of this data will then be statistically analysed using PSPP software, where any changes in dependent variables will be measured using a paired t-test. The paired t-test will compare the means and standard deviations of the data to see if there is a significant difference between pre-intervention and post-intervention. After a thorough literature review, the outcomes of this study are expected to align with the original hypothesis, that there is a reasonable expectation 12 weeks of probiotic supplementation will improve blood pressure, kidney function, and liver function in adults. As you can see on your screen, this is the proposed timeline for our research project. We've organised our timeline into a plan of significant project milestones. So we expect the initial proposal development and oral presentation to take about 8 weeks. While this is happening, we will be seeking ethics approval from the Queensland Health Human Research Ethics Committee, as we've noted previously. We also hope to secure this ethics approval by early March to begin our 12-week supplementation trial. Maintaining this timeline will leave us with 3 weeks post-intervention to perform statistical analysis and develop the final manuscript. So with that, we've now concluded our research proposal discussion for today. Thank you so much for listening, and the following slides you will see my references.